All right, Geometry, Chapter 3, Section 5, Parallel Lines and Triangles. Today's objectives, as you can read, is to use parallel lines to prove a theorem about triangles and to find a measure of triangles, the measure of angles for triangles. All right, one thing, we're going to do this in class, but you can do it as well. Cut out a triangle. All right, what is the sum of the angles, the measure of the triangle? Well, if you guys remember, we know it's 180, but here's a cool little thing you can do. Take your scissors and cut off the corners of each one, all right? And then when you pair them up, you're going to find out it makes a straight line. So angle 1, piece 1 would be right there, piece 2 would be right there, and then piece 3 would be right there, making a straight line. It's a pretty neat deal, okay? So we'll do that in class as well. So that gives you a great way to try it. All right, but how can we prove this? All right, the Solvix suggests an important theorem about triangles. To prove it, you'll need to use parallel lines. Through a point not on a line, there is one and only one line parallel to the given point. So that's our parallel postulate. So any point in the world to a parallel line, there's only one parallel line that exists, only one. So there's exactly one line parallel to point P, that through P, that's parallel to L. Okay, that's very important to know. So, and here's what we're going to prove. The sum of the measures of angles in a triangle is 180. So the measure of angle 1 plus the measure of angle 2, or B, plus the measure of angle C is 180. The proof of the triangle angle sum theorem requires an auxiliary line. An auxiliary line is a line that you add to the diagram to help explain relationships and proofs. The red line in the diagram below is an auxiliary line. So here's the proof. So we had a point P. Given, we know the triangle ABC works. We want to prove the angle A plus the measure of angle 2 plus the measure of angle C equals 180. So here's what we're going to do. We're going to draw a line PR that goes through B that is parallel to AC. So now we can use our angle relationships. All right, so angle A and angle 1 are congruent. Angle C and angle 3 are congruent. Okay, so let's just go through our steps now. Draw a line PR through B that's parallel to AC. We can do that with our parallel postulate, knowing through any point there's exactly one line that is parallel through that point to another line. Okay, angle PBC and angle 3 form a linear pair. Okay, so we're talking about this angle. Angle PBC and angle 3 form a linear pair. So angle PBC and angle 3 are supplementary. That's the definition of a linear pair. So we can say the measure of angle PBC plus the measure of angle 3 equals 180. So we can say the measure of angle PBC is nothing more than the sum of angle 1 and angle 2. So we can state with true relevance the measure of angle 1, 2, and 3 equals 180. Now we can say what we said earlier, the measure of angle 1 is congruent to measure of angle A, and the measure of angle 3 is congruent to the measure of angle C. So we can say the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 by substitution property. So we can prove that with multiple diagrams in figure 1, 2, and 3. All right, so here we go. Use the triangle sum theorem. What are the values of x and y? Okay, so let's look. What can we know first just by looking at x and ABC? Well, this little triangle has a sum of 180. I have two angles given, so I know I can say 43 plus 59 plus x equals 180. Because all we're dealing with right here is triangle A, BD. So 43 plus 59 is 102 plus x equals 180. So x, we're going to subtract 180 each side, is 78. So we're going to subtract 102 to each side. So if I know x is 78, I know x and y are a linear pair, so their sum must equal 180. So I know x is 78. So 78 plus y equals 180. I can subtract 78 to each side, so I'm going to get y equals 102. All right. Now that I know y is 102, okay, I can find z pretty easy. So let's worry about triangle BDC. Okay, we know the sum of those angles equals 180. So the measure of the interior angle of B is 49. The interior angle of D is 102. And the angle Z we do not know. So we got 49 plus 102. So watch my highlighter. So we got 49 plus 102 plus Z equals 180. Add them together. So I got 151 E plus Z equals 180. Subtract 151 to each side. I'm going to get Z equals 29. All right. So 78, 102. All right. 78, 102, and 29. So let's look at what we can prove from there. An exterior angle of a polygon is an angle formed by the side and the extension of an adjacent side. Okay, that sounds kind of confusing, but just hold on. For each exterior angle of the triangle, the two non-adjacent angles, all right, are its remote interior angles. In each triangle below, angle 1 is an exterior angle, and 2 and 3 are the remote interior. So what we're going to find out here is the remote interior angles sum always equal the exterior angle. We'll prove that in just a second. The theorem below states the relationship between the exterior angle and its two remote angles. The measure of each exterior angle of a triangle is equal to the sum of its two remote interior angles. Okay? So what is the measure of angle 1? All right? If we remember our theorem, we can just say the measure of angle 1 is the sum of the two exterior remote interior angles, which would be 80 plus 18, which would be 98. All right, let's say you totally forgot that. Can we find this measure right here? Yeah, because we know 180 equals that measure plus 80 plus 18. All I did was I summed up all three of these angles to find x, okay? So 180 is going to equal x plus 98. Subtract 98 to each side. We get x equals x is going to equal 82. Okay, so x is going to equal 82. So we know 1 plus x is a linear pair. So we know the measure of angle 1 plus x is a linear pair. So 1 plus the measure of angle 1 plus 82 equals 180. Subtract 82, the measure of angle 1 equals 98. So you get the same thing. It's just a lot easier if you look at it that way. So part B, what is the measure of angle 2? Okay, so we can say 124 equals the measure of angle 2 plus 59. Subtract 59 to each side. The measure of angle 2 equals 65. All right, what's the other way we could do it? Well, we could say this is x, and we know 124 plus x equals 180. Subtract 124 to each side. X is equal to 56. So we know 56 plus 59 plus the measure of angle 2 equals 180. 56 plus 59 is 115. So 115 plus the measure of angle 2 equals 180. subtract 115, measure of angle 2 equals 65. So you see, if you ever forget, you can always go back to what you know. All right, two angles of a triangle measure 53. What is the measure of the exterior angle? Two angles of a triangle form 53. What is the measure of an exterior angle at each vertex of the triangle? Okay, so let's draw that up. Two angles of a triangle measure 53. So let's get a triangle. So we know x, sorry, I lied. So that angle's 53, that angle's 53. What is the measure of what is the measure of an exterior angle at each vertex of the triangle? So that's easy to find, right? So this one is just going to be a sum of 53 and 53. So this one will just be 106. Okay, makes sense. This one, we got to find what this angle is. So this angle right here, what is it? 180 minus 106 equals x. How do I know that? Because I can go with a linear pair. So 74. So that angle's 74. So this one's just going to be 74 plus 53. What's 74 plus 53? 74 plus 53 equals 7. 127. So that one's 127. That one's 127. This one's 127, this one's 127, and this one's 106. All right, does everybody see how we got that? Last one, applying the triangle theorems. Okay, when a radar tracks an object, the reflection of the signal off the ground can result in clutter. Clutter causes the receiver to confuse real objects with its reflection, called a ghost object. At the right, there's a radar receiver at A, an airplane at B, and the ghost at D. What is the value of x? Okay, well, this is an exterior angle, so it's the sum of the remote interior angles. So we can say 80 equals 30 plus x. Subtract 30 to each side, so 50 equals x. So our answer is 50. So the answer is B. And again, if you forgot, you could say this is 100 degrees based on a sum of a linear pair. So the triangle itself is 180, so it'd be 100 plus 30 plus x. Okay, if you ever forgot that, you can just go 100 plus 30 plus x equals 180. 130 plus x equals 180, so x equals 50. All right. In problem 3, can you find the measure of angle A without using the triangle exterior theorem? Actually, we just did that. Okay? Please look this over. Make sure it all makes sense to you, okay?